Hello everyone, this is Monday the 24th of August 2020 and we are bringing you another medium New York Times Sudoku. I think today I'm going to go with a normal solve. I did a fast one yesterday. So what we're going to do is we're going to put in Snyder notations. So let's switch to candidates mode first because we're more likely to be doing pencil markings first until more numbers are resolved. Pardon me. So by Snyder notation, what we're going to do is in every single cage, we're only going to allow ourselves to put in two candidates, two pencil markings per digit, if possible. If we've got less, it means we know the number. If we've got more, we're going to leave them out for now. And hopefully I can demonstrate why that is useful. So let's start with the ones. I've got a pair of ones blocking rows 1 and 3. And I've got 1 down here blocking column 3. So that means there's got to be a pair of 1s over there. And I'm going to pencil mark them in. This one sees into these two cells. That gives us another pair of 1s. And in the remaining cages, we've got 3 possible candidates each. So there's not much we can do about that. Another 3 candidates here. So since we're going for the Snyder notations, we are not going to fill them in. We haven't actually got any 2s, so 2 is a weak number, and we're going to bear that in mind and see if we need that later. 3s, I can see these 2 3s, locks of 3 up here, so I'm not even going to bother explaining. I assume you'll understand the logic. So now these 2 3s, locks of 3 in 3 possible cells. So since it's 3, we're going to leave them out. We've got 4 possible 3s in this cage, we're going to leave it out. 3 possible, leave it out. 4 possible, leave it out. And another 3 possible, so we can't do any more pencil markings for 3. So we're going to go for 4s. Well, these 2 4s immediately locks a 4 in this cage. Cages, by the way, are a grid of 3 by 3 numbers. And this 4, in turn, looks over here. I can see a pair of 4s locking the columns. And this row is blocked out, meaning I've got 2 4s as a pair, so I'm going to pencil mark them in. Looking over here, actually, this 4 looks into this column, and these 4s look into these rows, so that actually locks another 4 in there. So now I've got another pair of 4s in these columns, which means I can pencil mark in another set of 4s, thanks to this row being blocked out. And I think that's all the 4s pencil marked in or filled in. So that's been pretty successful. Let's move on to 5s then. 5s. So at a quick glance, we can't actually do any pencil markings in for 5s because they either leave me with 3 possible candidates. 3 possible candidates again, or in some cases 5 possible candidates. 3 possible candidates, so that's not really useful for us at all, so we're going to skip ahead onto 6s. 6s, so we've got quite a lot of 6s here, so these 2 6s locks a 6 in that column in this cage, and there's only 1 cell available. And now we're gonna actually, I'm just going to carry on with the pencil marking. This 6 sees into this row, and this 6 sees into this column, so we've got another pair of 6s there. And this creates what's called a pointed pair. A pointed pair is basically, within this cage, this 6 has to be in these 2 cells. That means this row 2, is taken up already, because wherever the 6 goes in this cage, it has to be in row 2. So the rest of row 2 in these 2 cages are out of play. Most importantly, these 2 6s, and that's useful for us because when we look up with this 6, that blocks that cell as a column, so that means the 6 is pushed into that cell over there. And in fact, if we actually follow the logic here, these 2 6s also locks a 6 in here because of that 6 as well. And what else can we do? We've got another pair of 6s here because of these 2 6s locking the row and that 6 locking the column. And I think that is all the 6s we've pencil marked in. So let's move on to 7s then. So 7, if we look over here, that creates a pointer pair of 7s looking back across to the left. I'm working with this 7 blocks these 2 rows entirely, and I've got that 7 blocking that column, and that gives us another 7. So now these 2 7s locks that 7 in this cage, and these 2 7s in conjunction with a new 7 creates a pair of pencil marking. And I think, oh no, we've got another pair of 7s up here thanks to these 7s, but I think now we are out of places we can do, because we've got 3 possible candidates. No, actually, that's a lie. I've got 5 possible candidates for 7 in this cage, and we don't want to do that because that's going to leave us with too many pencil markings, and actually does more harm than good at this stage. So let's move on to 8. There's a lot to do with 8 actually. So this 8 locks these 3 cells, giving us a pair of 8s. So now they look down as a pointed pair, along with this 8 locks another pair of 8s here. This 8 also looks across to the left, creating another pointed pair of 8s. So we're going to use that with the 8 again and look over here, and that 8 blocks that column. We've got another another pair of 8s over there. So what else can we do? This 8 looks up, but we've got 3 possible cells. So I think that's all we can do with 8s. So why don't we look at 9s? That 9 locks that cell, this 9 locks that cell. So we've resolved the 9 in this cage, and now working together, along with that 9, blocks all these cells, giving us another 9. And these 2 9s, looking back to the left, works with that 9. So that gives us a pair of 9s, but if we look in this cage, the 9 has to be in column 2. So there's nowhere 9 can exist in column 2 and any of the other cages looking up. So this is a pointed triple, I suppose. But the important thing is, even though I haven't pencil marked in anything, by going through all the 9s together, I can immediately spot it and use it, even though I haven't got the pencil mark for it. So that locks a 9 in there, and these 2 9s locks a pair of 9s down here, and I think that's all the 9s that we can pencil mark in. So now we've gone through the entire board from 1 to 9, and we've filled in a fair few numbers. I don't think we're quite halfway yet, but we're not far off. So we can go and do another round right now, or we can have a little bit of fun and actually have a look at any weak areas within the board. And by weak areas, I'm talking about areas like this, where in this cage I've only got 2 numbers left, so there are only 2 possibilities, and they have to be, in this case, 2s and 8s. Unfortunately, that doesn't resolve in a solve, as in we can't actually deduce which number is the 2 and which number is the 8, or rather which cell is the 8 and which cell is the 2, so we just have to leave them there. But since we're pencil marking in within the cage, we can leave the 2 2s and 2 8s as they are. On the flip side, if we are working on a column or a row beyond the cage, then we're not going to pencil mark in the pairs at all, because it may confuse things in the future. What we can do now, though, is we can also look at, I don't think we have any more pairs of cells that we can look at, but we certainly have triples that we can look at. So triples, by that I mean in this row we've got 3 cells, in this row we've got 3 cells left. So those are also kind of weak areas, so it's always worth having a look at. So what we want to do is, on this row we've got 3 numbers left, so what we want to do is work out what are the 3 possible candidates for these 3 cells. So since we've got pencil marking of 8 here, we can have a quick scan and we can see there are no 8s existing in this row. So that means the pencil marking is still correct, and it's safe to say 8 is one of the possible digits, and we only have to look for the other 2. So at a quick glance, I think the other 2 are 5s and 2s. So what we want to do then is, we've got 2, 5 and 8 in these 3 cells. So in each one of these cages and columns, I want to have a look and see if I can see any of the digits. So for example, I can see an 8 in this column, so that cell sees an 8, but it doesn't see a 2 or a 5, So that's still yet to be decided. In this cell, actually I'm going to come back to this cell later. In this cell, we can't see, what was it again, 2, 5 and 8. We can't see any of the numbers. We can kind of see an 8, but the 8 is actually pencil marked in the same cell. That means the cell itself doesn't see an 8. It can still possibly be an 8. However, if we look at this cell, I'm going to pause for a second and see if you can figure out what this cell can be, because we can actually deduce the number. And if you haven't figured out already, the reason we can figure this out is because of this cage here, because this cage also has a triple weak area. Within the cage, we've only got 3 cells left. And incidentally, the 3 remaining digits, at least 2 of them are 2s and 5s. In fact, the whole thing is 2, 5 and 9. So this cell, out of 2, 5 and 8, can see 2s and 5s. So even though I haven't pencil marked them in, I think this is slightly more advanced. I haven't pencil marked in the 2s and 5s. If you're struggling a little bit, one thing that you can do is, there's no reason why you can't pencil mark in these numbers if they form a triple in a straight line, or if you've only got 3 cells left within a cage. I think it's fairly safe to do that, and it would have allowed you, if you didn't already, to spot that this cell actually sees a pointed triple of 2s and 5s, resolving the 8 over here. It may be quite hard to see without pencil marking them in, but that just comes with experience, basically, so don't stress too much if you didn't see it. Now this 8 is now going to erase the pencil marking of 8 over there and the 8 over here, so we actually can fill in the 8 in these 2 cells. And by filling in the 8 over here, we've actually eliminated one of the 7 candidates that we've pencil marked in. And all these pencil markings in are basically saying these are the possible cells with that number. So if you erase one, in essence, you're saying the only remaining pencil mark has to be where that number goes, basically. So that has to be a 7. And once you're more accustomed to it, you're going to find it's quite easy to find chain reactions where you fill in one number and it causes a cascade of numbers being collapsed into single digits, basically. So you might have noticed I've erased the 8 over here because of the 8, so this 2 and 8 pair has been resolved, and this 8 continues to work its magic, erasing another 8, and now it forms 2 8s in this column, and along with this 8 fills in another 8 over here, which first of all erases an 8 over here, filling in the last 8, but it also erased one of the 9s that was there. So by erasing the 9, it forces a 9 in the remaining cell within the cage, basically. So that's quite a chain reaction. That 9 also erases a 9 over there. But the most important thing it does is it now leads to a single cell left in this entire column. And if you do mental arithmetic, we can tell that it's a 1. And that leaves us with 2 numbers left within this cage. That's another weak area, so let's attack it. These are 2s and 3s. So unfortunately we can't see any 3s in either the columns or the rows. So we can't resolve them just yet, so we're just going to leave them be for now. So this cell, along with that cell, is also a weak area on this row. And we already know it's a 2 and 3 because this cell can be a 2 or 3. So there has to be a 2 or 3 as well because we've only got a pair there. Well, incidentally, this cell sees a 3, so it has to be a 2. So now we've just resolved the 2-3 pair within that cage. So now that 2 does 2 things. First thing is, but actually, does it do 2 things? Or I think it's this 2 that does one thing, and that 2 does another thing. So let's look at this one first. This 2 blocks those 2 cells, giving us another pair of 2s, so that's useful. This 2, on the other hand, works with these pointed triple of 2s, and they lock a pair of 2s up here as well. Oh, sorry, I need to drink some water. Okay, so what can we do next? We've got another pair here and another pair within these two cells. So let's look at what they are. These are 2s and 5s. So I can't see a 5 or a 2 in either of these two cells. What about here? That doesn't see anything either, so we're just going to pencil mark them in as 2s and 5s over here. Now you notice I haven't pencil marked in the 5 in this cell because in theory, you would want to pencil mark in the 2s and 5 in this row because those are the only candidates left. But what's going to happen is now that leaves us with a single 5 in this entire cage, and that puts us in a risk of thinking that we've got a single 5 here and just jump to the conclusion that we can fill that in. Basically, it will look like there's only one 5 in this cage, and you just assume that that's a 5. So that's the reason I don't do that. But we can actually resolve these 3 digits, I believe. Yeah, we can actually resolve these 3 digits. So I'm going to give you a second. And if you haven't guessed already, this is how we can resolve it. We've got a triple on this column. So this column already has 2s and 6s, but also a 5 because this is a 2-5 pair. So 2, 5 and 6 have to go in these 3 cells. Well, we've got a 5 in this cell, so we also have a 2 over here as well. So this cell cannot be a 2 or 5, so that's a 6. So that pushes the 6 out, which forces the 6 in here, 1 and 6. So now on this column, we've got a 5. And that leaves us with a pair of 2s and 5s. I lied actually, I thought we can resolve the 2 and 5 as well, but we can't just yet. But we can do the remaining digits in here. So these are 1s and 3s. Again, we don't know where they are just yet, but that's okay. We've pencil marked them in now. So as soon as we guess one of these, not guess, but once we deduce one of these values, they're going to collapse inwards into themselves, and we're going to get them all basically. So we've got a bit of a barren landscape over here, so we probably want to do some more pencil marking in. So although before I do that, I can see a 7 here looking into this pencil marking, so that actually forces a 7 in there. So now we've got a 1-3 pair, but 3 actually goes in these 2 cells, so that's this entire cage pencil marked in. What else can we do? 3, 3, so 3s are in these 2 cells. Now that carries an interesting property. So we know that 3s can only go in one of these 2 cells, but these 2 cells also include the 7 as well. So that actually forms a 3-7 pair. Since the 3 has to go in one of these 2 cells, and the 7 has to go in one of these 2 cells, there's no way any other digit can go in there. And what that does is, even though we had a pencil marking of 4, the 4 has to be pushed out, and that means 4 has to go there, and that resolves our remaining 4s. This 3 and 7 is, the other thing it does is it basically locks these 2 cells. It basically means no other numbers can go in here, and sometimes that's really helpful to unlock other patterns as well. In this case, it unlocks a triple here, but that triple would have been unlocked anyway by this column anyway, so let's pencil mark them in. We've got 1, 2 can go in all 3 cells, and 5s. So 2s and 5s go in all of these cells, so that's not super helpful for us. Anything else we can do? 2, 1, 3, 2, 1, 3. So that's another weak area. And we've got 3 digits left, and they are 2, 3, and what else is missing on this column? 2, 3, and 9. So can we see anything else? We can see a 9 on this row, but nothing else. So that means that's a 2 and 3 as well. So that's useful because these 2 cells are both 2s and 3s. That means the 9 cannot go in them. And in fact, we can see a 9 over here. and a 9 over there. So that actually forces a 9 down to the bottom cell. And that 9 now erases another 9, forcing the 9 in here. And I think that's all the 9s in this grid. So now something interesting has happened here in this bottom row. We've got 2 and 5, 2 and 5. Besides the fact that no other digits can go in the 2s and the 5s, the other thing that it means is 2 and 5s cannot go outside of these two cells where they are aligned, in this case as a row. If they're within a cage, then within a cage there can't be any more of these two digits. So if 2s and 5 can't go there, then 3s and 7 have to go in here, because those are the only values left based on the pencil marking, and I've got 7 up there. So that resolves the 3 and the 7 and the 3. And this 7 now locks a 7 in this cell, because these two 7s lock the rows, that 7 locks the column, and that's the last 7 in that in the grid. We are left with a 1, 2 and 5 triple here. I can see a 1 and 5 in this column, so this has to be a 2. But also, this was a 2-3 pair, and I already had a 3, so that was another thing that could have allowed me to resolve this 2-3 pair. Now with the 3 eliminated from this cage, the 1 and 2 are now resolvable, and that 2 comes up here, pushes 2 out, so that's going to be 5 and 2. And over here I've got 5 and 2. So that's the kind of chain reaction that happens. Unfortunately, the chain reaction are quite short in this instance. That 1 sees over the 1-3 pair, resolving them. And it also looks down here, meaning 1 has to be here, and that has to be a 5. So now we know that can't be a 1 or 5, it has to be a 2. So that erases 2, meaning 5 and 1 goes in there. The 5 looks over here, forces a 2 in and a 5 in, and that is how we solve today's medium New York Times Sudoku. I hope that's been helpful. Please leave a like if it has been, and if you want to see more in the future, please subscribe. I'll be doing this daily. And tomorrow I'm going to try and solve the medium Sudoku without using any pencil marking at all, which is another challenge. But if you'd like to see more kind of standard solving of medium Sudokus, please leave comments as well. Your feedback is the only way I can improve the channel, not that there are many viewers at the moment. I will just continue to work on this, and I enjoy it, so that's the number one thing. And hopefully I'll see you guys tomorrow. Bye!